Day 8, we're going to look at normal distribution and percentile rank again. To review, a normal distribution, let me make this bigger, sorry. A normal distribution is a set of data that is symmetrical about the mean of the data and takes on a bell-shaped curve as pictured below. A normal distribution is a very important statistical data distribution pattern occurring in many natural phenomena, such as height, blood pressure, lengths of objects produced by machines, etc. Certain data, when graphed as a histogram, creates a bell-shaped curve known as a normal curve or normal distribution. The smaller the standard deviation, the more concentrated the data. So what that means, the smaller the standard deviation, the less spread out. All right, so again, here is our bell-shaped curve, our normal distribution right there. Here are features of a normal distribution. Number 1, the mean and the median are the same. All right, so this line down the middle, here's the symbol X bar. This means mean, but in a normal distribution, it's also the median as well. The data is symmetrical about the mean, so it's a mirror image, and the mean is like the mirror. The spread of a normal distribution is controlled by the standard deviation. So that symbol right there, standard deviation, we've talked about spread of data. The percent of data that is one standard deviation to the left of the mean to one standard deviation to the right of the mean is 68. So what that is saying is, if you're one standard deviation away, that is 68% of your data. The next sentence says, if you're 2 standard deviations away, this is 95% of the data. So for example, if you're talking about height, most people, 95% of people, would be within 2 standard deviations of the average height. The percent of data that is 3 standard deviations to the left of the mean to 3 standard deviations to the right is 99%. So what that means is 99% of the data is within 3 standard deviations. That's most of your data right there. The empirical rule states that for a normal distribution, nearly all of the data fall within 3 standard deviations, so 99%. 68 falls within the first standard deviation and 95 within the 2 standard deviations. And then 99.7% about fall within 3 standard deviations. Okay, so again, we're going to look at these numbers and what they mean. But first, I found these videos and I thought that they were pretty interesting and related to this, so we're going to watch them first. Okay, so the first is about standard deviation.
Have we discovered a new particle in physics? Is a manufacturing process out of control? What percentage of men are taller than LeBron James? How about taller than Yao Ming? All of these questions can be answered using the concept of standard deviation. For any set of data, the mean and standard deviation can be calculated. For example, 5 people may have the following amounts of money in their wallets: $21, $50, $62, $85, and $90. The mean is $61.60, and the standard deviation is $28.01. How much does the data vary from the average? Standard deviation is a measure of spread, that is, how spread out a set of data is. A low standard deviation tells us that the data is closely clustered around the mean, or average, while a high standard deviation indicates that the data is dispersed over a wider range of values. Standard deviation is used when the distribution of data is approximately normal, resembling a bell curve. Standard deviation is commonly used to understand whether a specific data point is standard and expected or unusual and unexpected. Standard deviation is represented by the lowercase Greek letter sigma. A data point's distance from the mean can be measured by the number of standard deviations that it is above or below the mean. A data point that is beyond a certain number of standard deviations from the mean represents an outcome that is significantly above or below the average. This can be used to determine whether a result is statistically significant or part of expected variation, such as whether a bottle with an extra ounce of soda is to be expected or warrants further investigation into the production line. The 68, 95, 99.7 rule tells us that about 68% of the data fall within 1 standard deviation of the mean. About 95% of data fall within 2 standard deviations of the mean, and about 99.7% of data fall within 3 standard deviations of the mean. The average height of an American adult male is 5'10", with a standard deviation of 3 inches. Using the 68, 95, 99.7 rule, this means that 68% of American men are 5'10", plus or minus 3 inches. 95% of American men are 5'10", plus or minus 6 inches, and 99.7% of American men are 5'10", plus or minus 9 inches. So, this means only about 0.3% of American men deviate more than 9 inches from the average, with 0.15% taller than 6'7" and 0.15% shorter than 5'1". This reasoning suggests that LeBron James is 1 in 2,500 and Yao Ming is 1 in 450 million. In particle physics, scientists have what are called 5 sigma results that are 5 standard deviations above or below the mean. A result that varies.
I think that's all I showed in class. Let me just fast forward. Spread of data we'll talk about. Okay, so that's pretty much what I want to show you in that video. There's this other video. Oh, I should stop the video. Where it's a really cheesy video. You can click on the link and watch it. But the one example that I really liked in this video, he shows like wear patterns. So let me see if I can find it. Okay, again, super cheesy video if you want to watch it. I thought this one was pretty good. Okay.
Grab the receipt, and your action wears paint off the pump. You see the wear pattern here?
Yeah, but how is that statistics?
Well, it's a bell curve. Most people target the middle. Few are a little off to the right. A few are a little off to the left. But most target right in the middle. As lots and lots of fingers grab for their receipt, a bell-shaped pattern develops.
I see it now. A bell-shaped curve. All those fingers building up the pattern.
So I like that example. I think there was one more too, like the door. Let's see right here.
Here, at the drugstore, see the pattern on the door? It's a bell curve. More wear in the middle, less on either side.
So like whenever I go into a store now, I always look, is there that normal distribution? Most people, again, put their hand in the middle, and then fewer are on the sides. So just some things to think about. Okay, so let's go back to our lesson here. We are now on this page right here. It says, which of these curves represent normal distributions with different means and standard deviations? What do you notice? And right down here. So in class, we would talk about, all right, which one? It says, these curves represent normal distributions with different means and standard deviations. What do you notice? And so, again, it gives you the averages, it gives you standard deviation, and we would talk about things that you notice in every picture. So one thing that you might notice is the smaller the standard deviation, the less spread out. So if you notice the standard deviation is only 0.8, and the standard deviation is 2. This one's much more spread out than the 0.8. All right. You can look at the averages. The average is how tall it is at the top right here. This average is 10, this average is 8, so it's a little bit shorter. So again, in class, I would probably break you up into groups and we would talk about what we noticed. All right, let's do some more practice problems together so that you have enough to do your assignment. So this one right here, it says the time Elliot shows up late to school on any given day is normally distributed. All right, so when you see normal distribution, you can go ahead and draw your bell curve. All right, if Elliot shows 4 minutes late on average, okay, so there's the average, which is the middle, okay, so there's the 4. And the standard deviation is 2. What is the probability Elliot will show up on time or early on any given day? All right, so I'm going to go ahead and draw in our lines. There's 1 standard deviation out. Here's 2 standard deviations out. And let's go 3 standard deviations out. We know that the standard deviation is 2 minutes. All right, so 2 minutes. We're going to add 2 as we go to the right. So this would be 6. I'll just keep the same color, 8, 10. We're going to subtract 2 as we go to the left. So we get 2, 0, -2. So then it says, what is the probability Elliot will show up on time or early? So think about what these numbers represent. Which number here represents on time? All right, and again, 4 minutes late was the average. So on time would be this line right here at 0. 0 minutes late, and then the -2 would be 2 minutes early. So this is on time or early. And we need the percentages, so we'll use that empirical rule. I'll write them in. This is 34%, 13.5, 2, and 0.5%. So if we look at this normal distribution for Elliot, he has a 2.5% chance of being on time or early. So there's a good example of using our normal distribution curve. All right, let's try the next one. At the FBI, the ages of the top 10 most wanted criminals in the last 5 years are normally distributed. All right, so normal distribution, we can go ahead and make our curve right here. Within this curve, 95% of the ages centered about the mean range between 23.2 and 35.4 years. All right, so let's put in here's our average, and then we're going to go 1 standard deviation out, and we're going to go 2 standard deviations out, and that's 95% of the data, 2 standard deviations out. Again, if we look at our chart right here and add these up, this is 95% of the data. Okay, so let's put those numbers here. So it's 23.2 and 34.5. It says find the mean age and the standard deviation of the top 10 most wanted criminals. So earlier in this course, we've talked about how do you find the middle of two numbers. And if you can't clearly see what it is, one way to find the middle is to add them up, divide by 2. Find the average. That finds the middle. So we're going to take 23.2 plus 34.5, and then we'll divide that by 2. So that's how we'll find the average. I'll do it with my calculator. Give me 1 second. 23.2 plus 34.5. Divide by 2. All right, so that middle number, I'm going to do it one more time. 23.2 plus, oh, and I wrote this number wrong. I was thinking my number looked wrong, so I apologize. This number should have been 35.4. So switch those. Whoops. All right, so plus 35.4, divide that by 2. Okay, so our mean, the average or the middle of those two numbers is 29.3. Okay, it says find the mean age, done. There's the average age of a top 10 most wanted criminal according to this study. And then it says, what's the standard deviation? All right, so to find the standard deviation, what I'm going to do, and there's a few ways to do this. What I think I'm going to do is I'm just going to find the distance between these two, but this is 2 standard deviations, so then I'm going to divide it by 2. So I'm going to take 29.3 minus 23.2, and then divide it by 2 just to find that 1 standard deviation. So again, I'll type that in my calculator because it's faster than using my head. All right, so 1 standard deviation, if I did my calculation right, is 3.05. All right, so we can check our answer. I can add 3.05 and add it again, and I should get 29.3. So I'm going to take 23.2 plus 3.05 plus 3.05. Oh, and it worked. All right, so our standard deviation, so that sigma is 3.05, and the average, x bar, is 29.3. Okay, let's try a few more examples, and then again, you should have enough information to work on your assignment. Student scores on the ACT for the state of Minnesota for 2014 follows a normal distribution with a mean of 22.9 and a standard deviation of 4.3. The U of M requires a minimum score of 23 to be admitted. Estimate the percentage of students from Minnesota who are eligible for admission to the U of M on the basis of their test scores and explain their reasoning. Okay, so we can use our picture to explain our reasoning. Here's our normal distribution. And the average is 22.9. Standard deviation is 4.3. So we'll go ahead and go out 3 standard deviations. Oopsies, that was a highlighter. Okay, so we're going to add 4.3 as we go to the right, subtract 4.3 as we go to the left, and really what we're looking for is this number 23. Oh, and that's right in the center, right? So this is about 23. Okay, so I don't even have to fill in the bottom because I'm looking for what percent is above 23, and that's half of our data, right? We're right down the middle, and this is about 23. So we would say about 50% of students who took the ACTs in Minnesota would be eligible for admission. So about half is above 23. Okay, next question. What does percentile rank mean? And it means the percent below a certain point. So let's use that to figure out 5 and 6. It says the math test scores were as following. Find the percentile rank for a score of 84 on the test. And if you've noticed, I have put them in order, so that's nice. Otherwise, if they weren't in order, we would put them in order. And we want the percentile rank for 84, so we're going to find 84, and we're going to look at everything below. And percent is what you want divided by the total. So let's count how many scores are below 84. 1, 2, 3, 4, 5, 6, 7, 8. 8 scores out of 8. I better double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. I get 20 total scores. Hopefully that's right. So then to find the percentile rank, you would divide 8 divided by 20 and find that decimal. So it's 0.4. Oops. And if you multiply that by 100, we get 40%. So if you scored an 84 on this test in this particular set of data, you would be in the 40th. Let's write that neater. You'd be in the 40th percentile. Which means that you did better than about 40% of the students who took the test. So again, it's the amount below you, the percent below you. Okay, let's take a look at number 6, last one, and then you'll have a chance to work on the assignment. 2 curves representing normal distributions are shown. Does the solid curve or the dashed curve have a greater standard deviation? And remember, the greater the standard deviation, the more spread out the data. And if we take a look, it would be the dashed line looks more spread out. So we would say the dashed, more spread out. Okay, so that should be enough information for you to try your assignment, which starts on page 36. Again, the answer key I'll put on Google Classroom. Let's see, it just is page 36. Oh, that's nice. That's it, just page 36. Try it out, check your answers.